Hello, amazing people, and welcome to today's video. And in today's episode of Question for the Day, we're dealing with the concept of balancing a chemical equation using the algebraic method. My name is David, the billionaire teacher who takes the mystery out of chemistry so you can make history. So without any further ado, let's get into what we have for today's video. Alright, so the algebraic method of balancing chemical equations have a number of steps. The first step says to use letters to represent the coefficients that should be in front of every compound. So we have this equation Al2SO4 3 plus CaOH2 giving us AlOH3 plus CaSO4. So when this equation is balanced, there are certain coefficients that should be standing in front of each compound over here, and over here. So what we're going to do is to use letters to represent them since we do not know what they are. So for the first element or the first compound I meant to say, let's represent the appropriate coefficients using the letter A. So we have A standing in front of Al2SO4 3 plus, let's use the letter B to represent the second coefficient. So we have B in front of CaOH2. And then thirdly, we have the letter C standing in front of AlOH3. And then finally, we have the letter D standing in front of CaSO4. I'm sure you saw how we carried out that process. So the next thing to do is to form equations for each and every element or polyatomic ion that we have in this equation. So the first element we have is the element aluminium. Now aluminium appears here on the left hand side of this equation. It has a subscript of 2 and the coefficient is represented by the letter A. So that tells us that on the left hand side, the number of atoms of aluminium we have is 2 multiplied by the letter A. On the right hand side, you can see aluminium appears here. It has no subscript, or its subscript is 1 even though it's not identified, and its coefficient is the letter C. So on the right hand side, we have C multiplied by 1, which is C. 2 multiplied by A here is 2A. So according to the law of conservation of mass, when you are balancing a chemical equation, the left hand side must be equal to the right hand side. So that tells us that for aluminium, the left hand side, which is 2A, must be equal to the right hand side, which is the letter C. This is the first equation. Now the next thing we have over here is a polyatomic ion, which is the sulfate ion SO4. It appears on the left hand side and it also appears on the right hand side. So we have SO4. Alright, now somebody might be asking, why didn't we deal with them individually? Take sulfur first and then oxygen next. Well, we took the entire polyatomic ion as a single unit because you can see it is enclosed in a bracket. And on the place where I dealt with, I have a series where I talked about balancing chemical equations, and then there is a part where we talked about polyatomic ions. Polyatomic ions do not break down in a chemical reaction. So for instance, if you started with SO4, on the other side of the equation, you will still have SO4. And when balancing equations that have polyatomic ions, you treat the ions as a single unit. So that's why we're treating this SO4 here as a single unit. I hope you understand that. I trust you do. So SO4, the ion has a subscript of 3 identified here. You can see. And its coefficient is the letter A as shown here. So for SO4, the number of units we'll have will be 3 multiplied by A, which is 3A. On the right hand side, you can see over here, SO4 has no subscript, or its subscript is 1. If I close this in a bracket, you can see SO4 appears only one time. Alright, and its coefficient is the letter D. So on the right hand side, the number of times SO4 appears is D multiplied by 1, which is D. So equating the left hand side and the right hand side tells us that 3A is equal to D. That is the second equation. I'm sure you saw how every step is being taken. The third element we have is calcium. Now calcium appears here on this equation. You can see calcium has no subscript, or its subscript is 1, even though it's not identified. And its coefficient is represented by the letter B. So we have B multiplied by 1, which represents the number of atoms of calcium that we have on the left hand side. B multiplied by 1 gives us B. And on the right hand side, you can see calcium appears over here. Alright, calcium has no subscript, or its subscript is 1, and then its coefficient is this letter D. So we have D multiplied by 1, which is D. So for the third equation, equating the left side, which is B, to the right side tells us that B is equal to D. This is the third equation. And then finally, we have the hydroxide polyatomic ion, OH. So you can see OH on the left hand side, it appears 2 times, okay, or it has a subscript of 2. You can see over here, and then a coefficient of B. So for OH on the left hand side, it becomes 2 times B, which is 2B. On the right hand side, you can see OH appears here, having a subscript of 3 and a coefficient of the letter C. So we have the right hand side being equal to C multiplied by 3, which gives us 3C. So as far as OH is concerned, if we equate the left hand side to the right hand side, we have 2B is equal to 3C. This is the fourth equation. So now that we have the equations for all the units in this chemical equation, the next thing to do is to find out the values of each letter. How do we do that? We simply take any letter at all, any one, and then we assign a small whole number to it. So let's do that very quickly. At this point now, we want to find out the values of each letter. So we can take any one at all. We can take A, B, C, or D, whichever one we choose, okay? And we assign a small whole number to it. So let's take A for instance, and let's assume or assign the number 2 to it. Let's say A is equal to 2. So this first equation will now become 2A is equal to C. Now we know the value of A to be 2. So that tells us that anywhere we see the letter A, we insert the number 2. So therefore it becomes 2 multiplied by 2 is equal to C. So C will now be equal to 4. So we have the values of A and we have the value of C, which is 4. This second equation now will now become 3A is equal to D. We know the value of A to be 2. So therefore D will now be equal to 3 multiplied by A, which is 2. Therefore it becomes 6. So we know the value of A, we know the value of C, and we know the value of D to be 6. I'm sure you're following. The third equation says B is equal to D. We know the value of D to be 6. So therefore B will still be equal to 6 since B and D are equal. So we know the value of B as well. B is equal to 6. And then we have the last equation that says 2B is equal to 3C. We have the value of B over here. The value of B is 6. 2 times 6 is equal to 12. And we have the value of C, which is 4. 3 times 4 is equal to 12. So we know all our values now. So let's impute them. A is equal to 2. B is equal to 6. C is equal to 4. And D is equal to 6. At this point now, we can balance the chemical equation. How do we do that? Remember, at the start of this exercise balancing this equation, we assigned variables. We said A should stand in front of Al2SO43 plus B should stand in front of CaOH2, and then C should stand in front of AlOH3, and then letter D should stand in front of calcium sulfate, CaSO4. So now that we know the values of A, B, C, and D. Will simply substitute the values. So A is equal to 2. Therefore, we have 2Al2 SO4 3 plus B. B is equal to 6. So we have 6 CaOH2, giving us C is equal to 4. We have 4 AlOH3 plus D. Our D is equal to 6. So we have 6 CaSO4. So this, my friends, is our final balanced equation. But there's something I want you to take note of. All these coefficients are not in the lowest term. What I mean is, there is a number that can divide 2, that can divide 6, that can divide 4, and that can divide 6 as well. And that number is the number 2. So if we divide by 2 to have in our lowest term, this now becomes Al2 SO4 3, since 2 divided by 2 over here is 1, okay? And then 6 divided by 2 gives us 3. So we have 3 CaOH2, yielding 4 over here divided by 2 gives us 2 AlOH3 plus 6 divided by 2 here gives us 3 CaSO4. This, my friends, is our final balanced equation. And to be double sure, we can check the number of atoms of each element on both sides to see if they tally. The first element is aluminium. You can see aluminium has a subscript of 2 here. On the left hand side, aluminium appears 2 times. And you can see on the right hand side, aluminium has a coefficient of 2. So 2 on both sides means aluminium is balanced. The next element, or polyatomic ion should I say, that we have is SO4. SO4. On the left hand side, SO4 has a coefficient or a subscript of 3. You can see it over here, right? And then we have SO4 over here as well. It has a coefficient of 3, which means it appears 3 times. So on both sides, SO4 is balanced. The third element we have is calcium. Calcium, you can see on the left hand side, appears 3 times. On the right hand side, calcium also appears 3 times. 3 means calcium is balanced. And then finally, we have the hydroxide polyatomic ion, OH. On the left hand side, it has a subscript of 2 multiplied by a coefficient of 3, which means it appears 6 times. On the right hand side, you can see over here, it has a subscript of 3 and a coefficient of 2. 2 times 3 means it also appears 6 times on both sides of the equation. So this equation is perfectly balanced. I'm sure you enjoyed every bit of this, from the point where we assigned letters to represent coefficients, to the point where we formed equations, and to the point where we balanced it fully. If you did, please like, share, and subscribe. And I'd be more than willing to see you in the next episode, where we deal with more questions and solve more naughty issues concerning topics in chemistry. It's been a pleasure being with you. Once again, my name is David, the billionaire teacher. All I do here is to take the mystery out of chemistry so you can make history. I will see you in the next video.